Okay, first thing I'm going to do is talk to you about what it means to solve an equation. What it's asking for when it says, where is cosine theta this height? So if we were to go to, I'm going to see if I can, so I've got desmos up on here now, right? This is, let me go ahead and see if I can annotate that. Let me do this real quick. I don't know. That's going to let me. All right. So, darn it. I don't think it's going to let me. Okay. So here's the graph. This is the parent cosine graph. At 0, we're at a height of 1. At 2 pi, we're at a height of 1. At pi, we're down here at negative 1. All right. So when it was asking, where is cosine the height of root 2 over 2? And that's about 0.7, about 0.7. So maybe right about there. Right here. And right here. If we zoomed out with desmos, we would say that's pi fourths, and that's 7 pi fourths. That's what this is asking about. All right, let me go back to this. Okay, the other way to look at it is on a unit circle, cosine values are positive in these two quadrants, right? Because the x is positive in this direction, x's are negative in this direction. So where is cosine positive? Well, it would be in the first, right? And if you were looking, if your eyes were on your unit circle, you would see the x value of root 2 over 2, and the x value there, positive root 2 over 2. And on the unit circle, you would see, well, that's pi fourths. That's 7 pi fourths. All right, so I wanted you to understand graphically what the sine graph is doing if you're looking at the unit circle. And now I'm going to show you algebraically what you need to do. All right, well, what we want to do is get that theta by itself. So when we were solving triangles and we wanted to find out the measure of an angle, we did this. Those cancel, leaving the theta. But if we take the arc cosine, or what looks like inverse cosine, and then when you type this in to your calculator, this is going to give you 45 degrees. But we want it to be in radians. So instead of putting 45 degrees, and you could just convert that, remember 45 degrees times pi over 180, and that's going to give you 1 pi over 4, or pi fourths. So you could figure it out that way, or you could look at the unit circle and say, oh, the x value is positive root 2 over 2 at pi fourths, and then in the fourth quadrant, ta-da! And those are your two solutions. So that's what you're doing on all of these. All right, we're going to go through 8 of them. So now we've got a negative value. So then where do you look on the unit circle? Well, the x values, remember, cosine, think about it as the x or as the adjacent, right? So for the x's are negative in the second and third quadrants. And so right about there, you've got a negative root 3 over 2. And right about here, you have a negative root 3 over 2. Those are just the x's. The x's are the cosine value. All right. So on paper, we're doing that inverse cosine of both sides. Now be careful when you're putting this in your calculator. Make sure to close that parentheses before you hit the divide. Then go ahead and close that parentheses right there. All right. Now, when you type this in, you're going to get 150 degrees, which is right here. If you look at your unit circle, that's 5 pi over 6. Or type on the calculator, and you're going to get 5, 6, and then the pi goes right there, right? So you could do it that way if you wanted. And then in the third quadrant, 7 pi 6. Okay, now let's come down here. We've done 2 cosine. Let's go with sine now. So the sine, these are the y values in the coordinate points. Well, first of all, the y values are positive above the x-axis. So in the first and second quadrants, and the y value is a positive 1/2 right there, and a positive 1/2 right there. Going, well, that's easy. That's going to be the 30 degrees. Yep, that's right. But on paper, and then when you type that in, that first theta you're going to get is 30 degrees. Well, 30 degrees is pi 6. Remember what I said over here, that pi is the same as 6 over 6? So 1 less than 6 over 6, so subtract 1 over 6, you're going to have pi over 6, 5 pi over 6. When you add 1, well, that doesn't matter. We only need the 5 pi over 6. And that just happens to be 150 degrees. The only thing I really care about is the radians. And again, we're looking at the unit circle and coming up with that. Okay. When you get to this one, now all the time when we're solving, don't start writing yet. Just kind of pay attention to what I'm saying, because I'm going to show you kind of an easier way to do. Typically what we would do is we would do this to both sides. I don't want you to do it that way. The easiest way is, let's just think about these two as separate fractions. So write this as negative 6 over 2. And then here, maybe you can just, kind of put a line through it. And then root 3 over 2. Well, this thing right here, negative 6 divided 2, is negative 3. So those two just cancel each other out. See, we didn't have to do the distributive. We didn't have to do any of that. All we had to do is think about them separately. And this number and this number were the same on each side of the equal, so they canceled each other out. So all we have left is cosine. Well, again, when you're looking at the unit circle, cosine is positive. Oops. These two quadrants. And the x value, the cosine value, is root 3 over 2 at 30 degrees and 330 degrees, or pi 6, 11 pi 6. So when we take our inverse, or our arc cosine, it's another way to describe that, probably a better way. When you type this in, you're going to get 30 degrees, which is pi 6. And remember, all the way around the circle is 2 pi is 12 over 6. So subtract 1 from that, and this is 11 pi 6. or 30 degrees and 330 degrees. All right. Now this one right here, we need to get the sine by itself, sine theta by itself. So we're going to add 4. By the way, if you forget the thetas when you're doing this, and you think, well, no, that's too much of a hassle, I'm just going to write sine. This is meaningless. Your math just became meaningless. The only way that any of this matters is because we're talking about the viewpoint from a specific angle. And that's the theta. So the theta is critical. All right, when we add 4 to the left side, I'm going to write 4 as 8 over 2 because now 8 halves subtract 7 halves is just positive 1 half. Those two cancel. And now we're ready. So those cancel. And then remember, sine is positive. The y values are positive in the upper 2 quadrants. And the y value is positive 1 half or positive root 1 over 2, however is your preference. And again, you type this in right here, you're going to get 30 degrees, which is pi over 6. And over here, pi is the same as 6 over 6, so subtract 1. That's the same one that we had above. Okay. Now this one's an interesting case. We want to get the cosine by itself. So we're going to add 3 to both sides. Oh, sorry, I went the wrong direction. I need to pay attention to what I'm doing. We need to get the cosine. The cosine's on the left side. So add 2 to both sides. So cosine theta, negative 3 plus 2 is negative 1. When you're looking at the unit circle, there's only one place where the x value is negative 1. And that's at pi. So we're going to take the inverse cosine of negative 1. So this is pi is 180 degrees, or we just put, there's only one solution for this equation. Because there's only one place where the x value on the unit circle is negative 1. Now, there's a y value that's negative 1, but that's not the x value. There's only one place for the x and only one place where the y is negative 1. All right? This is going to be like the one that we did before. We're going to pretend like it doesn't exist like this. And we're just going to write that as 2 fractions. And then 8 divided 2 is 4. So those cancel each other out. And now we have cosine theta is equal to negative root 2 over 2. Again, cosine is negative over here. You're looking at the unit circle. The x value, remember cosine is the x value. At 3 pi-fourths and at 5 pi-fourths. So we take our inverse cosine. Now, when you take the inverse cosine and you do this, as long as you're doing it correctly, a negative sign there, close the parentheses, do not put the negative on the inside of the radical, you're going to get 135 degrees. Well, that's 3 pi-fourths. And then in the lower quadrant, quadrant 3, you get 5 pi-fourths. All right, that's this one on solving equations and then what that looks like on the unit circle, what that looks like on the parent graph. And I'm going to do another video for the stuff that we covered today on coterminal angles. All right, that's it for this one.